Horizontal force F is equal to mg divided by 3 is applied on the upper surface of a uniform cube of mass m and side A, which is resting on a rough horizontal surface having static friction, coefficient of static friction as half. The distance between the lines of action of the mg and the reaction force n will be equal to. Now first of all over here, if I consider that there is a body, there is a cube and the force is applied over here, and the edge over here, the any side of the cube over here will be equal to A, okay, and the force is applied on the top surface of the cube, so the force is applied somewhere over here, okay. The force applied will be equal to mg divided by 3, okay, and there will be a force, okay, there will be a force mg in the downward direction, okay, there will be a force mg that is its own weight in the downward direction, okay. So basically over here, well, there is a friction at the bottommost side, okay. This friction over here will be equal to in the opposite direction, which will be equal to mu mg. Let us first find out whether this body will slide or it will have more tendency to topple. Now the force I am applying is mg divided by 3. The force applied is equal to mg divided by 3, and the force due to the friction, the maximum force due to the friction will be equal to mu mg. Mu over here is equal to half, so it will be equal to mg divided by 2. Since the friction force is greater than the applied force, okay, the body will not move, the body will not have any translational motion and it will have a tendency to topple, okay. So it will have a tendency to topple. Now over here, when there is a tendency to topple, it will topple when I am applying force, let us say about this point, okay, about this edge, the body will have a tendency to topple about point A, okay, about point A, the body will have a tendency to topple. So now let us find out the clockwise and the anti-clockwise torque, and let us first find out what is the clockwise and the anti-clockwise torque, and how do we balance the normal force over here, and how will the normal force balance this part. First of all, when I consider about point A, the body will start rotating about point A or topple about point A. So the torque produced due to mg by 3 will be in this direction, that is in the anti-clockwise direction, and due to mg it will be in the clockwise direction, okay. So basically it will be equal to mg by 3 into, over here the perpendicular distance over here is equal to A. This is the torque produced in the anti-clockwise direction, and the torque produced in the clockwise direction is equal to mg into A by 2, okay, mg into A by 2, it will produce a torque in the clockwise direction, okay. So in order to balance this, there will be a normal force, which acts somewhere over here, let us say at a distance x from point A. I do not know the value of x over here, but it will be equal to x from point A, okay, and this has to produce, since the torque in the clockwise direction is greater than the torque in the anti-clockwise direction, it should be there should be a certain normal force, let us say this normal force over here is equal to n, and it will be at a distance of x, okay. In the equilibrium position, torque produced in the anti-clockwise direction will be equal to the torque produced in the clockwise direction. So the torque produced in the anti-clockwise direction is equal to mg by 3 into A plus the normal force over here. The normal force will balance the vertical force, which is equal to mg. So it will be equal to mg into, over here the perpendicular distance, I do not know the perpendicular distance, let it be equal to x, will be equal to mg A divided by 2, okay, will be equal to mg A divided by 2. So over here mg and mg will get cancelled out, x will be equal to x over here will be equal to A by 2, and the perpendicular distance over here is A by 3. So basically x over here will be equal to A by 6, okay. So they have asked the distance between the lines of action of mg. So the distance between mg and the normal force, mg has a distance of A by 2 and n has a distance of A by 6. So basically n will be on the left hand side as compared to mg. So it has so the distance between them will be equal to A by 2 minus A by 6. The distance between them will be A by 2 minus A by 6, which will be equal to A by 3. Therefore the correct answer will be option number B. The normal force will act at a distance of A by 3 from the mg.